Hi Kevin, here's your assignment for Unit 4. Just a few little corrections that I wanted to go through with you. You're doing really well. I've just drawn little sort of more U-shaped parabolas over top of your V-shaped ones. You have to be really careful because the V shape is actually the graph of another function. It's the graph of the absolute value function. When you're drawing a parabola, it has to be a nice smooth curve in a U shape. And I know those U's can get more skinny and more spread out depending on the A value, but you've got to keep that nice smooth curve and not indicate that there are straight lines. There's never a straight line in a graph for a parabola. So let's just have a look down here. The axis of symmetry, you had left blank on question 2A and B. Your axis of symmetry is just the line that goes through the center of the parabola. So if we have a parabola here, then the axis of symmetry will actually, create a mirror line right down the middle. The point where it crosses the parabola is actually the vertex, and the vertex we know is PQ. So all you have to do for axis of symmetry is take the p-value from the equation. In this case, the p-value is 1. So it's x equals 1 for the first one, and then x equals minus 4 for the second one. Question 3 looked great. You expanded those perfectly. The question 4 and 5 was the same thing in both cases. For these questions, you start with substituting in P and Q, which they give you as the coordinates of the vertex. And so over here, I've written my first line, y equals a times x minus 4 squared plus 3, using the P and the Q values. The other hint that we have about the a value is that we have a point xy that's 2, 6 on this parabola, so the curve must pass through it. If you try to put 2, 6 in for xy in the equation that you gave, you'll find that the equation doesn't balance on both sides. In other words, you don't get the same value on both sides, so that tells you that that point can't possibly be on that parabola. The way that we do this is we're going to substitute in the 6 for y, the 2 for x, and we're going to work out the equation because the only unknown we have is a, and so we end up with 3 equals 36 times a, or a equals 1/12. And so your final equation should be a equals 1 over 12, quantity x plus 4 squared plus 3. I've done the math for you over here for question 5 as well. In this case, the coefficient a turns out to be 2 over 81, negative 2 over 81, my apologies. And the way that you can check to make sure that your answer is right before you hand a test in like this is to take the point you were given and sub it in for x and y and make sure that both sides come out the same. And if you get in the habit of checking your answers, it takes just another minute or two on a test. That's going to help you bring up your overall mark on tests and assignments by as much as 10 or 20%. And so it's really a good habit to get into, and it's a really good idea if you have time left at the end of a test in a regular class. Wherever you're able to substitute your answer back into an equation to make sure it works, then you're going to catch all sorts of little mistakes like that, and you can go back and correct them before you hand it in. Okay, question 7 looks great. That one's perfect. And then question 6 at the bottom here, I really like that you're doing them out of order. I really encourage students to do that as long as your work is nice and neat and teachers can see which question you're working on. It's a much better strategy to do all the ones that you're really sure of first and leave the ones that might be a little bit more difficult to the end. That way you're a little bit more relaxed because you know you've answered all the other questions, and all the time you have left you can just relax and concentrate on this one that you're having trouble with, and then you end up being able to think more clearly and getting more marks. So that's a really good strategy. Just wanted to point out to you in question 6 that you don't need to find the axis of symmetry using this equation. You already have the axis of symmetry because it's contained within the quadratic equation. It's just x equals p. And so if you have a 3, t minus 3 in that bracket, then you already know that your axis of symmetry is going to be x equals 3. And that tells you the x-coordinate for your max or min point right away. That's why it's so important to be able to put it into this completed square form, into the p and q form. So when you're doing a question like that, just try to remember that. It's a big time saver. And again, if you made a mistake when you were calculating it over here, then all of your work here would be wrong, which it isn't. It's perfect. And everything else looks good too. So just a few little minor things for you to look at. Just review those because they're really, really important. And when you're going on next year, if you're taking grade 12 math, then you will need to do some more of this stuff. So just make sure that you have really, really good background on it.